Vertical stretch and vertical compression, and we're gonna pick up where we left off yesterday. And so we learned that if we put a number larger than 1 outside in front of the function, that was a vertical stretch of our function. We stretched all the y coordinates of our function. We multiplied them by that factor. And if it's less than 1 is the number in front of the function, then we compress the function. We multiplied all the y coordinates by that much, and we compress the function. And so on this example here, we have the graph of y equals f of x below, and we're going to consider the function y equals g of x, and that's going to be 3g of x minus 2. And so first thing we want to notice about our g of x, or our new function, is that there's going to be 2 transformations that's going to occur to this function. So what 2 transformations do we see occur? So one we talked about yesterday. So do you see a transformation that we talked about yesterday happening to g of x equals 3 f of x minus 2? If you need help, pull out your transformation rules chart and look back at that. That's sort of our cheat sheet for this unit, and it has all our transformations on there. If you need an extra copy, just let me know because we have extras. So there's this number in front of our f of x, that 3. That number is going to represent a vertical stretch by a factor of 3. So our first transformation is going to be a vertical stretch by 3. So that's our first transformation. The second transformation is one that we talked about, and it should have been one of our first transformations. And it comes from this negative 2 on the outside of the function, or outside the parentheses of the function. And so when we see minus a number on the outside of the function, what type of transformation is that going to represent? You need to look back at your transformation rules chart. So it would be the minus c, or f of x minus c on your transformation rules chart. What is that going to represent? Oscar? We're going to go down 2 because we're minus 2. So we're going to have a shift down by 2. So these are the 2 transformations that we're going to do to our f of x function, or f of x quadratic that we have right here. Oh, I don't know what that is. Okay, so in order to graph g of x, we have to do both of these transformations. The question now is, though, which transformation do we do first? Do we shift down by 2 and then we multiply by our vertical stretch of 3? Or do we multiply by our vertical stretch of 3 and shift down of 2? We're going to multiply first, because if we think order of operations, or PEMDAS, which is parentheses, exponents, multiplication, division, addition, subtraction. Or you may have learned, please excuse my dear Aunt Sally, or some other mnemonic device to help you remember these. So vertical stretch is when we multiply the number. So multiplication right there. And then a shift down would be subtraction. We're shifting our y coordinate by 2. So that would be subtraction. And so multiplication in order of operations comes before subtraction. So we're going to do our vertical stretch first, and then we're going to shift. And so when we do our vertical stretch, just to remember from yesterday, we look at each of our points that we have on our graph, and we look at the y coordinate of that point. And then we're going to multiply that y coordinate by our vertical stretch. So in this case, for our vertex is -3, -1. So the y coordinate of -3, -1 is negative 1. We're going to take negative 1, we're going to multiply it by 3, which is our factor of our vertical stretch. So negative 1 times 3 is going to be negative 3. And then after we have our new point, we're going to shift it down by 2. So we take our new point, shift it down by 2. So we're performing both transformations. You can either do both transformations to a point and do that for each point, or you can do one transformation to all the points and then do the second transformation to all the points, as long as you're consistent with what points get the transformations and you don't mess up. So that's why I would recommend using multiple colors. We have the color pencils up here if you really want them and you want to use them again. They're free to grab. But as long as you can do one point, you can do it vertical stretch and then shift, or you can do vertical stretch to each point and then shift each point. It's up to you, just as long as you're consistent. So we're going to do the same thing with our other points. So negative 4 is 0. The y-coordinate of this point is 0. So we're going to multiply 0 by 3, which, what does that give us? 0. And so vertical stretch point is still going to be there, but now we have to shift it down by 2. So we're going to go 1, 2 below, and that's our transformed point. The same with negative 2, 0. 0 times 3 is 0. Then we minus 2, or we shift down by 2. So our new point is negative 2, negative 2. So negative 1, 3. 3 is the y-coordinate. So we'll take 3 and multiply it by our factor, which is also 3. So what is 3 times 3? 9. And so our vertical stretch point is up here at 9, but when we need to shift it down by 2 to get both transformations, so 9 minus 2 will give us 7. And then our other point, which is negative 5, 3. Once again, 3 times 3 is 9. Shift down 2, we get 7. Oh, wrong color. And so we can connect all of our points. And this is our new graph that was transformed. It has the 2 transformations, the vertical stretch of 3 and the shift down of 2. And this graph was g of x. We saw from. So hopefully that was a little bit of a review from yesterday after the shortened period. Are you guys still coloring or writing it out or moving on? Are you guys okay to move on? Thumbs up, thumbs down. And so, if the quadratic function g of x has y equals 2 as the y-intercept, or y equals 12 as the y-intercept, which of the following is true about the function h of x equals 3g of x minus 5? We need to explain the reason and show our work. And so, what 2 transformations do we see from 3g of x minus 5? Jordan, sorry.
Stretch by 3.
So we see a vertical stretch by 3. And this comes from having the 3 outside the g of x. And what is our other transformation, Tiffany?
0, 5.
So we have another shift down 5. And this happens because we have the minus 5 after our function. So after the g of x, we have that minus 5. That represents a vertical shift down by 5. If you need help remembering these, look at your transformation rules chart. And so we know we're going to have 2 we're going to have two transformations, a vertical stretch by 3 and a shift down by 5. What point did they tell us was on our original function? The y-intercept is 12. So we know our y-intercept always has an x value of 0, and they said the y-intercept was 12. So which is the y-coordinate of our y-intercept? Is it going to be 0 or is it going to be 12? Yeah, the y-coordinate for our y-intercept is 12. And so we need to take 12, and 12 is going to be the number that we're going to perform our transformations on, because we have our vertical stretch by 3 and our shift down by 3, which are both transformations in the vertical direction. Which transformation should we perform first? The stretch or the shift? The stretch, because in our order of operations, our stretch is multiplication, which comes before subtraction, which is our shift. And that comes from the PEMDAS, which we looked at on the last one. And so we're going to take 12, and we're going to multiply it by 3. What does that give us? 36. So that was our vertical stretch by a factor of 3. And now we're going to take 36, and we're going to shift it down by 5. Oh, 36, I'm sorry. 6. Yeah, 36, and we're going to shift it down by 5. What would that give us? 31. So that was the two transformations to the y-intercept. So what answer of our problem are we going to choose then? Oscar? D. So it has a y-intercept of 31. So hopefully we're starting to get the hang of these. We can start remembering or memorizing our transformation rules, and we'll get a little bit more familiar with these. So take a moment and try to do this first part of the problem. So on the graph below, sketch 1/2 of f of x. And so what is going to be our vertical stretch, or are we going to have a vertical stretch, or are we going to have a vertical compression for this one? If you need help, look at your transformation rules chart. We're going to have a vertical compression, because if we look, the number in front of our function is 1/2, and 1/2 is less than 1, so it's going to be a compression. So we're going to take all of our numbers for our y and multiply them by 1/2. It's going to be the y values, or the y coordinates, are going to be multiplied by 1/2, and that's going to be your new coordinate. And so hopefully you should have been able to recognize that you take each point and then you find the y coordinate of it. So in this case our vertex is -2, 6. So we would multiply 6 by 1/2, which would give us -2, 3. So we would do that with all our points. And you get a graph that looks roughly like this. So now try the same thing, except now we're going to apply two transformations. We have a graph of -1 or 1/2 f of x minus 2, or with the 2 on the inside of the parentheses. So what two transformations do we see occurring to this graph now? Jordan? So we have a vertical compression by 1/2 again. What other transformation do we see? Oscar? A shift right 2. And this shift right is because our -2 happens inside the parentheses, or it's inside the function. So we're shifting to the right by 2. So which transformation should we perform first? Tiffany? Multiplication by 1/2, and then we shift each point to the right by 2. So take a moment and try this on your own. And so for this function, we should have done the same thing we did with the last one. We take each point and we multiply it by 1/2. Then we shift to the right by 2. So we have -2, 3, and we're going to go 1, 2 to the right. And so our new point is 0, 3. And we would do that for each point. 1/2, shift to the right. 1/2, shift to the right. And when we get our new function, that's vertically compressed by 1/2, and then shifted to the right by 2.